Welcome back to lesson 1.4. We're on example number 3. We're going to be looking at average rate of change. This is a huge concept that you first started building your foundation on in junior high when you started talking about slope. Last year we talked about it when in algebra 2 when we started getting into quadratics, and we talked about the average rate of change being the slope of the secant line. And it's going to be a huge part of calculus next year when we go from average rate of change on to instantaneous rate of change, which is a big portion of the first semester of calculus. But today we're just doing average rate of change. Just as a review, average rate of change is the slope of the secant line between 2 points on a curve. So if I want to find the average rate of change between x1 and x2, I draw a secant line, a line that goes through those 2 points, and we want to find the slope of it. Now, slope is just using the slope formula like we've used since junior high, f of x2 minus f of x1 all over x2 minus x1. Now, if you're at home saying, wait, I don't remember that, think of it before we learned about function notation, you probably learned it as y2 minus y1 all over x2 minus x1. It's probably how you saw it back in junior high. When we got into function notation in algebra 1, algebra 2, we moved on to this notation, and that's the notation we'll use today. So here we want to find the average rate of change for this function, and A wants us to do it between f of negative 2 and f of negative 1. So between negative 2 and negative 1. So I'm going to make this my x1 and my x2. So I want to find f of x2 minus f of x1 all over x2 minus x1. Well, x2 is negative 1, so this is f of negative 1 minus 1, which is negative 2. Whoops, just kidding, is f of negative 2 all over x2, which is negative 1, minus x1, which is minus a minus 2, will make it positive 2. So now I'm going to actually plug it into my function up here. So f of negative 1, I'm plugging in negative 1 into my function. I've got minus a minus 1 cubed plus 3 times negative 1. This is just f of negative 1. And from this guy, I'm going to subtract off f of negative 2. So we're going to plug in negative 2. So minus negative 2 cubed. There's so many negative signs going on. You have to make sure you have real good accounting of where your negatives are. Whoops. For example, there's a negative right there. So 3 times negative 2. So this piece here is f of negative 2, f of negative 1 minus f of negative 2. And this is all over negative 1 plus 2, which is just 1. All right, so let's see if we can boil this down. Negative 1 times negative 1 times negative 1 is negative 1 times the negative 1 makes it positive 1. 3 times negative 1 is negative 3. Minus, make sure you keep your parentheses in there because we don't want to lose this negative sign out here. So inside the parentheses, I've got negative 2 cubed. That's negative 8 times negative is positive 8. 3 times negative 2 is negative 6. So 1 minus 3 is negative 2, minus 8 minus 6 is 2. Negative 2 minus 2 is negative 4. So the average rate of change between negative 2 and negative 1 of this function is negative 4. Let's do the same thing, but this time we're going to do it between 0 and 1. So I've got f of 1 minus f of 0 all over 1 minus 0. So this would be negative 1 cubed plus 3 times 1 minus 0 cubed plus 3 times 0. Doesn't matter. I'm going to put parentheses around it. It doesn't matter on this one because it's 0 and it's going to go away. And that's all over 1 minus 0, which is 1. Negative times 1 cubed is negative 1. 3 times 1 is 3. And then that's minus a whole bunch of zeros, all divided by 1. And so 3 minus 1 would be 2. So my average rate of change between 0 and 1 is going to be 2. All right, go ahead and pause the video. Take your stab at you try A and B. Come back when you think you have it. All right, welcome back. Let's see how you did. So we've got f of 3 minus, f of 2 all over 3 minus 2. And I'm going to put this down here. So I've got 3 cubed minus 2 times 3 squared minus 3 times 3 plus 2. Don't forget that plus 2. I almost didn't see it. And then minus, I'm going to put parentheses because that's negative has to distribute to all of them. 2 cubed minus 2 times 2 squared minus 3 times 2 plus 2. And that's all over 3 minus 2, which is 1. Now 3 cubed is 27. 3 squared is 9 times negative 2 is negative 18. Negative 3 times 3 is negative 9 plus 2. Over here in the parentheses, I've got 2 cubed, which is 8. 2 squared times negative 2 is negative 8. Negative 3 times 2 is negative 6 plus 2. 27 minus 18 minus 9, they cancel out, and I'm just left with 2. And then minus, over here, 8 minus 8 is 0. Negative 6 plus 2 is negative 4. So I've got 2 minus a minus 4. That's 2 plus 4, which is 6. How'd you do? All right, let's try again with B. So we got f of negative 3 minus f of negative 5 all over negative 3 minus a minus 5 is going to become positive 5. So f of negative 3 is going to be negative 3 to the 4th minus 6 times negative 3 squared plus 4 times negative 3 minus, don't forget your big parentheses, negative 5 to the 4th minus 6 times negative 5 squared plus 4 times, running out of room, 4 times negative 5. 5 minus 3 is 2. Okay, so negative 3 to the 4th, that's going to be 81. Negative 3 squared is 9 times negative 6 is negative 54. 4 times negative 3 is negative 12. And then in my parentheses, negative 5 to the 4th is 625, if I'm not mistaken. Negative 6 times negative 5 squared would be 25, times negative 6 would be negative 150. And then 4 times negative 5 would be negative 20. All right, see if we can do this mental math. I'm going to actually cheat, and we're going to go to a calculator here. And we've got 81 minus 54 minus 12. That's all equal to 15. So this first part here is 15. And then in our parentheses, we got 625 minus 150 minus 20, and we get 455. And I can't write it under there. It's all divided by 2. 15 minus 455 would be negative 440 divided by 2, and we should get negative 220. How did you guys do? All right, that's it for example number 3. Example number 4 is going to be more average rate of change, but with some lovely application problems. That's coming up in the next video.